maybe we can't. All right, here we go. I'm not going to read the book out because I don't want to. I may read like passages. When we do these text heavy chapters, it's kind of hard for me to do them because it's not an audiobook. You know what I mean? If you want an audiobook, that's a different thing. Anyway. Just programmed in C before. The absence of a go-to statement. Man, go-to is so confusing. I've seen some code with really this morning. Man, bite. I've seen some Fortran code with goto, and it's really hard to reason about. Although, like, my ability to read and write code is a lot better now, so maybe I would kind of understand it. I don't know. Probably not. Spaghetti. Wait, is that true, though? I'm kind of curious about this. I mean, okay, maybe not like mainstream languages. Don't people just use like preprocessors to not do goto, but like skipping code and stuff? Or is that for mostly like choosing implementation details? But global state. Yeah, we avoid global mutable state. Anyone can change data at any time in any module. Very problematic. Tight coupling. Mm-hmm. Yeah, makes sense. Mm-hmm. Hey, about. Yep, makes sense. This is where I'm reading, by the way. Yeah, I would agree with this. Like, managing mutable state can be very tricky and easy to do wrong. Yeah, const is not really const from my understanding. Again, I'm not a huge JavaScript person, but yeah, I've heard about this, but I haven't looked at it yet. I think this is like an interesting point, just generally. Yeah, these language features require the developer to be disciplined on a daily basis to avoid. I mean, it doesn't have to be mutations; it can be just about anything. But like, you can write functionally in lots of different languages. It's just that your languages don't force you to do those things, which can be a problem. Not every language is like this. I think that, I mean, there are certainly languages that allow mutation of variables. Forget everything you learned in math. I don't. Nobody told me this. Luckily, if somebody told me this, I would have been really depressed. I guess. I'm trying to think. I'm not sure that I actually know what I remember my first programming class. I mean, like, I know what I took. I took like a a programming 101 course and I did Visual Basic and it was way too easy and the professor didn't push me at all. So I wasn't it just became very uninteresting to me. And it turns out now I'm a software developer. Yep. Evaluate it. Yep. Ooh, we see some PureScript code. Actually, we should probably like, if I see code, we'll try and write some of it, and hopefully there will be like exercises in this chapter. I think Spago doesn't make a new directory, so we should be fine. So I think we can just make dir chapter 2. Sorry, this is chapter 1. Okay, I don't have Spago, so we gotta go get it. Unfortunately, there's no... Maybe there's description of how to install this later, or I skipped those details, which I don't remember, if I'm honest. But Spago, PureScript. Yep. I think you can just get it with npm. Yeah. And I have that thing set up where this isn't actually global as far as I know, so I don't need to sudo this thing. And then we also need pure script. And then actually I'm kind of worried that this isn't working. Oh wait, no, it did work because I got a message from that person. No, I don't want to try. I want to get. Installing the compiler. Thank you. Okay, yeah, so this worked because I didn't get a permission denied. So we'll get this. And we might as well get the language server. Okay. And then all I need to do is quickly find the instructions. So nvim something like this. Yeah, here we go. I think that this is in here. It always takes me a second to find. I think it's here. Yep. Okay. Then we just gotta find PureScript ls, and it's called PureScript ls. So I think that we can just open up. Oh, well, this actually turns out to be a little trickier now because of the way I did this. Config nvim, and we need to adjust our lisp.fennel code to include PureScript ls, like so. So, if you haven't been to the channel before, my vimrc is written in fennel. So, anyway, we have to change that, and then we can nix build, which will I already have fennel installed, but this will do everything that I need to do. and it will give me a new lsp.lua that should include the thing. Okay. Anyway, so spago init. Okay. And then now we should have this, so we can start writing in our main file. Okay. Oops. So in theory, now we should be building a project. All right. So we have to write algebra problem. Nope, like this, and this thing's gonna return an int clearly. And r equals 3, and I think it's just in oh, okay, well, we can just do in s minus b minus r, and I think that this will compile. I haven't done Typescript in a while, so we just have to do it like this. Yeah. So one thing you're going to notice a lot in Typescript and Haskell, etc., is we tend to not use very large variable naming. And I don't know if that's true in this entire book, but ideally you will see something like this attached to it, number of students or whatever, but it can be pretty tricky sometimes when you're dealing with code you haven't seen before. Okay. In functional programming, compiler does the same substitution that we learned as kids. We say s equals 20. We're asking the compiler to allocate some memory and then call it s. What we're doing is defining s as the value 20. S equals 20 is an expression. Referential transparent, if it can be replaced with its value without changing the program's behavior. So referential transparency, an extremely important concept in really any programming language. If you can trust that your functions are referentially transparent, that's a very strong guarantee that they won't change over time, which is really nice. Hey, Dota, thank you so much for the follow. Really appreciate that. How's it going? Are you a programmer? It looks like you like Dota. I've never actually played those games. Hi, Kitty. You can see Layla here. Here, I'll go full screen for a second so we can say hi to the cat. Look up here. Look up here. Say hi to everybody. Okay. Oh, thank you. Okay. So what are some of the special things about Haskell? What do you have something in specific in mind, like what languages are you familiar with, and then I can try and come up with some like easy comparisons. I just need some context for the question is all. Okay, yeah. So as an example, like we'll go with TypeScript because, or well, we can go with Java, but I'm less familiar with Java. So Java is like an object-oriented language, right? Everything exists in objects. And there was actually an interesting point earlier in this chapter about how like you can just have like essentially a global object that contains like a bunch of variables that end up being global anyway. And so when you're like mutating global state, programming becomes really hard. Like the less you can mutate things, the better. So it's statically typed and the types are stronger than in Java. And also like Java continually adds features from Haskell and like people really love them, even if they complain about them at first. So I don't know, that's kind of interesting. For TypeScript, TypeScript still has all the same problems that JavaScript does, where like everything's a string. Sorry, this cat is really needy right now. Hi, buddy. Um, and so you still have like all of these issues that you wouldn't have um, weird behavior. I mean, yes, so like there's this common thing about learning functional programming languages where you have to first forget like everything you know about imperative ones, which I think is incredibly true. So, yes, you would find the behavior of Haskell and PureScript maybe not behavior, but like writing it will feel really odd at first. But once you get used to it, you never ever want to go back to writing it the other way. I have a really, really hard time like um oh yeah, yeah. So we can talk about that here in a second. Um but I have a really hard time writing like imperative code now because I don't really know how to write code without ADTs. Come on, you're really annoying right now. When I'm talking into the microphone, she wants attention. Um, yeah, I lost my train of thought there. Um, yeah, programming without ADTs and pattern matching is really hard for me now. Stay down, please. Okay. Next thing is yes, everything in Haskell is lazy, technically non-strict, but like the difference is pedantic for our conversation here, and that is okay in some cases. Like the creators of Haskell have said before that they would make Haskell lazy again if they had the choice. There's certain cases where laziness is not good for you. Um, like if you're doing a lot of data manipulations or like data pipelines, um, depending on the kinds of data structures you're doing and how much of them you're modifying, my understanding is that strictness is better. There's actually a talk by my colleague recently about how we really should just be using strict Haskell, and so I've not done a ton of benchmarking for Haskell code, but strictness can matter a lot when you're dealing with performance. There can be this issue where like you basically have like memory leaks. They're not technically leaks, but it's memory that's hanging around for a lot longer than you were expecting. So yeah, it can be really tricky. Yeah, I mean, like, it's kind of funny that you say this because, like, well, okay, if you're doing web programming, like front end web programming, Haskell is really problematic. Not problematic, it's just really hard. So, yeah, I would agree that that's not great advice for that. But, like, I'm a back end Haskell engineer. That's my job. So, you can get a job doing it, but it's not particularly nice on the front end. However, PureScript is really nice on the front end, and so is Elm. So, doing Haskell is definitely a weird choice in that context. Um, yeah. Yeah, but if you're doing front end, you definitely want to, well, maybe not definitely, but I think a lot of people would suggest doing PureScript or Elm over Haskell. Yeah. There is something called IHP, which exists that is like an MV. What is it? It's not MVC. It's something else, but it's kind of like a Haskell integrated environment for doing a website. Yeah. So the thing for me is ADTs, abstract data types, uh, first class pattern matching, because pattern matching is the most powerful thing in any language. I don't care what anyone says. It's, well, maybe what I should say is it's absolutely my favorite way to write programs. ADTs and pattern matching, and then really strong type guarantees, which are not true in languages like TypeScript. Um, again, I don't know that much about Java, so I shouldn't crap on Java, but you know, Haskell has a very strong type system. Not the strongest. Like there are stronger type systems, but then they make writing real programs a bit harder. Okay. The testing libraries are sweet. I don't know if you've done generative or property-based testing before, but there's a library, for example, called Quick Check, which will basically just generate a bunch of like edge cases for you, and so you can define like a property, I don't know, like if you add 1 to a number, it should always increase, something like that. Yeah, so there's definitely lots of great testing libraries as like Quick Check is the one of the coolest things I've ever used. I've actually also messed with programs that will generate tests for you. So like you say, like the program will go through like the algebra of your code, and it will implement tests based on your code. So you, like let's say you were doing a mathematics library or something, and it could find like relationships between functions, and it will actually build those and then generate tests for you that are property based tests. Yeah, yeah. If you're doing TDD, that makes sense. This is kind of like, this is usually from a design perspective. You design this like really small algebra or some tight algebra that you want your API to look like, and then it will generate these property based tests that you can then implement to test against. So it's kind of like a symbiotic relationship between the algebra of your program and the tests, if that makes sense. And it can generate tests that maybe you hadn't thought of, and it could generate tests that maybe you're like, wait, that's not really how I intended to write this algebra in the first place. And so I think it's kind of an interesting tool. I've not done it a bunch, but it looks very interesting to me. Okay, that was kind of a huge aside, but it's an interesting conversation for sure. Did I say thanks for the follow? I think I did, but I appreciate it. Yeah, there's a funny statement in here that I agree with a lot in the chapter we read before. It's like, oh, maybe you're referring to the algebra symbiotic thing. But there's a funny way that Charles says this in the first chapter. He says like it's kind of hard to explain functional programming until you just try it and like you get used to it and start doing it, because I don't know, it's definitely very interesting. Okay, so yeah, here's the lazy concept. So S will be replaced only when it's needed, since the language is default lazy, and it only evaluates what it needs when it needs it. That's the important context. And actually, it's a little different. So the technical term is non-strict. It's really not lazy. If it was truly lazy, then we would have more memory problems with Haskell than we do. It's just that Haskell can choose when it wants to evaluate things, and that's the non-strictness. PureScript is actually strict, so it eagerly evaluates everything, so you don't have that problem. And if you like talk to the PureScript folks, I think that they would tell you that they want strictness, which I think is true because this compiles to or transpiles to JavaScript. Okay. Yep, we get all the benefits of referential transparency, which is huge, because you don't. I don't know what you mentioned, JavaScript and TypeScript and Java. Not sure what languages you write on the daily, but like, when you have referential transparency, you don't need to test as much as you would, because referential transparency is a very strong guarantee, which you can't guarantee in Java. Like somebody could just run in and change something and do an effect or something here or there. Okay. Anyway. Yeah. Yep. I've heard of Spring, but again, I'm not a traditionally trained software engineer, so I never saw Java. I actually have written Java recently, though. All right. In math, there are no loops, but it's still a powerful enough language to define things like loops. Let's look at the factorial function in math where n is greater than 0. So n factorial is 1 times 2 times 3, da 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 da, n minus 2, n minus 1, n. Yes, makes sense. Yeah, there's, I don't know. I don't know enough about the OOP, but I have heard that as well. That Java is technically not a pure OOP language. Okay, so we have this. We can write this backwards. We see the following grouping. 5 times 4 times 3 times 2 times 1. which is just 4 factorial. And so we can write this. What are you guys doing? My younger cat is messing with the older cat. They're not that far in age difference, so I'm not too concerned about it, but it's kind of funny. Okay, so how do we calculate 0 factorial? Okay. Oh, that's cool. Nice. Yeah, chemistry is fantastic. Okay. Yep. 0 factorial is 1. Here's our mathematical definition. Here's some more mathy symbols. This symbol here is like for all n is a variable in all real numbers. Actually, I think that this is all natural numbers. Oh yeah, it's right there. Natural numbers. N factorial is n times n minus 1 factorial. Okay. Natural numbers are the counting numbers, is equivalent to this. Yep, great. And if we were to write this in JavaScript using like very boring code, we have a result, we loop and multiply, and we return the result. Great. Yes and no, agreed. Like you still have recursion. Okay. Yep. That's basic definition. Cool. Yeah. So here's the recursive definition in JavaScript. There's also the we'll just assume it takes an int. Yeah, the declarative stuff is becoming a lot more popular as well. Yeah, that's true. But again, that stuff is popularized by this. Actually, I think I have to do this. I don't think I can do pattern matching like that in PureScript. Well, we should try it because I'm not even sure. So factorial n equals n times factorial minus 1. Except I want some spaces here like that. Okay, so right, this is recursion, and this is super popular, and also one of these things, just since Dota is here, well, not since you're here, but since we're talking about like imperativeness, this is something that you see all over the place that you got to get used to, kind of. To be fair, like when you're doing practical everyday Haskell, like there aren't that many recursive functions, but I guess that's just the way we design our code at work. You'd be amazed at how much easier it is to reason about things like trees when you write recursive programs. Like, because you only have to think about the patterns that you're matching. So I actually disagree that it's harder to maintain recursive programs than imperative ones. Yeah, agreed that it's like certain things recursion makes your life easier, and there are other things that recursion can make your life harder, but you can choose not to use recursion in that case. But when you're working with like trees and the kinds of data structures that people work in, lists, streams, etc., recursion is incredibly useful. Yeah, but like even think streams or lists. Looping over lists is incredibly boring. It's, I don't know. There's very cool things that you can do with recursion that you wouldn't normally be able to do with, or well, that could be tricky with a loop, I guess. I don't know. I think I just really like writing recursive functions because it makes me think more mathematically about the code that I'm writing. Um, yeah, yeah, like this is a great statement to that, like what we're talking about. Nice. I love exercises. Give me exercises. That's what we want to do. Oh, that's cool. I don't know which library they're referring to here, so that'll be interesting. Okay, so let's look at some mathematical functions. So f of x. So another thing that I really like about um, like purely functional languages is you have to write functions, right? You can't like just um, you can't take functions that do a bunch of effects and like they just say they don't return anything, uh, or functions that don't take input, for example. Like those aren't things because these are built from the lambda calculus. Okay, so they do the following. So I think we're talking about purity here, which is like an important concept. Um, Take one or more inputs, perform a computation, return one result. Nice. Function and math are rigorous. However, blah, blah, blah. JavaScript. Yeah, so here's a wild function. We're taking something and then increasing a global work counter and then logging it, I guess. So yeah, like I think PureScript doesn't actually have any direct libraries, or not that I know of anyway, to database implementations. Although I haven't looked at it that much. So like because PureScript compiles directly to JavaScript, you would actually probably write like a node, use some kind of node library that touches database, and then you would like write up a wrapper around that thing. I don't know if those exist, if I'm honest, but in Haskell, I'm very familiar with something called Esqueleto and persistent. Es- Sorry, typing is slow. So let's see if they have an example on the front page. So this is kind of what persistent looks like. Typically, you write it in something called template Haskell, which is actually a problematic thing for some people. But this defines like a data type and also the representation on in the database. And so here's like a select. Let's just focus on this part. But you write things like this: select from person do blah blah blah. So it's like a pretty nice embedding of SQL in here. I don't think they have the experimental syntax in here either, but when you start, oh yeah, they do. Nice. So when you start doing joins and stuff, this is kind of what they end up looking like, which again is probably a little tricky to read at first, but it reads pretty naturally once you get used to it. So anyway, there's like functional database library, but yeah, database very declarative, so it makes sense. All right, there's no return in this function. Its return value is undefined, so why call it? Uh, you probably won't like Haskell then. It's people love lenses, which are just getters and setters, more or less. And I don't know what command query. I write command/query for my functions. I don't know what that means. Okay, so this value returns undefined, so why call it? We call it for its side effects, which are incrementing a work counter and writing to the console. In purely functional programming languages, yeah, it's fine. You don't have to. Like I can say that, like I know what getters and setters are, and that's essentially how Haskell does like complicated data manipulation. Maybe that's true in. I don't really. Yeah, I'm not sure how to address that. I don't know what encapsulation means in this context. Um, if I'm honest. Again, we could talk about this if you wanted to. I'd be interested, but not right now. Um, okay, so take one parameter, perform a computation, return one result. Functions like this are called pure. They have no side effects, and they, given the same input, will always produce the same output. Yeah, so very important. They're memoizable. Notice that these requires differ from the mathematical ones. Here, our functions can only take a single parameter. You might think that this is terribly limiting, but it's not. Turns out that any function with multiple parameters can be written as a set of functions that each only take a single parameter. Yeah, currying is really powerful and saves you a lot of headaches. Okay. They've taken away something that we've all gotten used to, doing side effects whenever and wherever we like. If you think about it, any program that does not produce side effects is producing no valuable work. Yeah, so I think that it's tricky when you're talking about immutable data structures, right? I think I understand what you're saying now. Um, yeah, exactly. Because we're not talking immutable data structures and in a side effectful world, then yes, getters and setters would violate encapsulation. I see what you're saying, and I think I understand what encapsulation means as well. But we're talking about immutable data structures in a world where we can't do side effects. So I think the game changes quite a bit when those are your requirements. Okay. Anyway, yeah. Uh, the I think the immutability and side effectfulness change everything about programming, right? Like in this function here, this factorial function, I can't do anything. I can't log output if I wanted to because there's no way to do that. And the data structure S here is completely immutable. I can't do anything to it. So if I have to set or get, well, I guess set because get wouldn't do anything. If I have to set something, I'm returning an entirely new data structure. It's changed, like, and you have to do that. Like you can't change the value of s. Okay. So yeah, no valuable work. It just runs while heating up the CPU. I think that this is kind of interesting, like no valuable work, because there are like proof systems, I guess, do no valuable work in this context, although they do produce side effects like logging or whatever. Um, no files are written, no HTML code is sent or received, no updates are made to the database. Yeah. Okay. Yeah, so one thing that's kind of interesting in I guess this book, which is true, is they don't even show you how to write hello world at first because writing hello world requires you to use this effect type. And so I think they just avoid it right away and we just talk about other stuff first. But we'll talk about this effect type later. There's an effect and an affect um, for different types of like synchronous or asynchronous effects. Yeah, this is so funny. I like this joke. Okay. Yeah, this is kind of tricky. Kind of a tricky way to explain around the fact that you can't do side effects. So like this, so I can kind of explain it now. This is technically a side effect. Oh, the joke is just the first thing I learned was Hello World, and when I learned Haskell, it was the last because performing effects is hard in Haskell. Harder, I guess. Like once you know how to do it, it's not that bad. But this program describes a pure program. When you run it, it produces the side effect. That's kind of how you talk about this. Although I don't know, it's a little awkward, and I don't remember the full argument. There's probably a better argument I could come up with. Anyway. Mm-hmm. Yeah. All right. So when you only use pure functions, there's some hidden benefits. What letters? Hey, thank you so much for the follow. Really appreciate that. How's it going? Tell me about you programming experience. Is pure script something you're interested in, or you know a little bit about it? Uh, Chat is open for anyone. You can ask whatever questions you want. I'll try to answer whatever I can, but I mean, I'm not that great at anything. Yeah. Okay. Memoization. This hard to pronounce term defines a technique of storing the results of expensive calculations so that the result can be looked up instead of recalculated. Let's look at this toy example in JavaScript. So we have this function which takes v and iterates to what looks like 10 million and does something complicated, prints it out, or like prints out that we processed the thing, and then returns v. Okay. I checked out PureScript, but due to work, just haven't pursued it anymore. Seems pretty neat though. Yeah, it's really cool. I'm a big fan of PureScript. I've written some halogen code, and I would like to write more halogen, but that's not the purpose of this particular book. This is just to put some beginner-friendly stuff on my YouTube, which, by the way, is here. Yeah. So I have like a ton. Every stream that I've done on books is pretty much on my YouTube. So if you have any interest in that, feel free to check it out. I don't have the previous version of this up yet because I would need to edit it, and that takes me too long. Editing is really hard. Okay. Anyway, one. Imagine some long calculation here. Thanks to this line G. Line. Oh yeah, G is not a pure function. This is G, the function. Okay. Since G is not pure, we cannot memwise the computation, but why? If we call G twice with the same V, it will log to the console twice. If we call G once with V and remember its result, memwise it, and then if we simply look up its stored result, instead of calling it a second time, we will only see the log to the console once. Yeah. Very similar thing for me. I ran up. When we were writing Elm in Action, I ran into a few cases. I had learned Haskell before that, so I ran into a few cases in Elm where I was like, I just don't understand how to do this well, and it just seems like a lot of work. And PureScript seems like less work because you have a little more abstraction. Yeah, sure. Okay. Oh, this looks horrible. Okay, so Gcache is, I guess this is called a, I don't know what this is called, a dictionary? A map? What are they called in JavaScript? I'm just going to call it a dictionary because that's the term I'm familiar with. So now we have MG object. Thank you. Yeah, that's true. I would agree with you. Letters. Object. Okay, so mg is a function that takes a v and looks for that value in the cache. If it's not there, we compute it with g and then store the result in the cache. And then we return the value of g in the cache. Or sorry, of the result in the cache. There we go. Yeah, I just wasn't sure what it was called. Like, I usually just call these either dictionaries or maps, depending on what language I'm talking about. But because I'm unfamiliar with the term here, I used dictionary, which is the Python version, or the Python name, which is a dynamic programming language. Yeah. So like every pure function in a pure functional programming language is memoizable, and that's like actually one of the requirements for functions in a pure language. Yeah. Okay. If you like ML style langs, I actually haven't checked out any ML style langs. I've seen really good things about F#. A lot of people actually, I have an F# book right here. This is one of the next books that we'll do on the stream. Domain modeling made functional, which is an F# book, but I might do it. I might do the book in Haskell, so we'll see. But yeah, I haven't done any ML. Heard good things about that. That's good. So have I, which is why I bought it actually. I'm a big fan of textbooks, but I did hear good things. I wouldn't buy an F# book if I didn't hear good things about it. But I want to start that actually probably this week on the stream. So that's kind of the plan. Maybe we'll start it tomorrow, actually. I don't know if you'll have time, but yeah. Okay. All right, so we looked at this, we kind of read it, and I mean, if you didn't understand memoization, hopefully I think this should be enlightening enough for you to understand. Yeah. I don't think, I think F#, like I've seen F# code before, so I don't think it would be that problematic for me to learn. I'm actually kind of more interested in learning a Lisp next. I would like to do some, like the SICP book, and I also have the Crafting Interpreters book. And so that would be the scheme. And then, well, the next one's C, but I kind of don't want to write C. So, it's Java and C, if I understand correctly. So we'll see. All right. So this is just explaining. Yeah, this is another thing that's big. Like compiler optimizations are easy when you're talking about pure languages. Because you are restricted by your compiler. Okay. Here's an example of compiler optimization, I guess. Toy example. Okay, so we have a function g. It's very funny to me that he uses g and not f, since f is usually... Oh, well, there's f right here. Never mind. Okay, so we take a v. We do something complicated. We say g was called with, and then we return the input value, which is weird. Not the result. Well, I guess we have to do something. So anyway, here we go. G is not pure. Yep. F of g of x. Yeah. Yep. FGH is what I would do as well as a scientist, I suppose, and a programmer, at least in Haskell. Okay, so there is a case for optimization here when n equals 1. I guess, because we're returning 1 minus 1, so this whole function is 0. I don't understand what this is asking me. It would be nice if the compiler would automatically optimize out the 2 calls to g when n equals 1. wouldn't it not matter what G is equal to because we're returning V? Shouldn't it optimize this out no matter what N is? Why? What? Stupid bot sending me. Anyway. Okay. Oh, well, okay. I guess that's the point, is that G is not pure, so like it doesn't matter. But I think that it wouldn't matter what N is, because it's always going to be N times 0. Oh, wait, no. I'm stupid. PEMDAS. I just twittered myself because I put in an order of operations question. Anyway. All right. Let's make G pure. Cool. Cool. And then we could do some optimization. Great. It's kind of a goofy example of optimization, I suppose, but sure. All right. Types. Oh boy. Look at this. There are two kinds of types in programming languages. It's not. I'm not convinced that it's poor. It's just like, it. I understand what the point they're trying to make. I just don't. But I also can't think of a great example of this. It's like, I mean, just putting this here changes the way you can view this, right? Like that's the point. If G performs side effects, there's nothing you can do here. Like you can't have any guarantee about what G is, and so even trying to do some optimization doesn't make any sense. So I think that that's probably a good enough point. But I guess if you've never thought about that, then you need kind of an example. All right. So static types and dynamic types. Static types are checked at compile time, and dynamic types are checked at runtime. There's also, I guess, like uni-typed languages where every type is the same, or like, yeah, there's only one type, which is a form of dynamic type, I suppose. Yeah, so like one of my one of my choices these days is if I'm learning a new language or somebody presents me a language and they say, would you use this language? If you tell me that it's a dynamically typed language, I will say I am not interested in said language. Like that's a strong no for me. Okay. Yeah. Java is dynamic. I thought Java would be static. Sorry. I read the problem. Or I read your thing backwards. So I think technically, like, I can assign types and then violate them at compile. Yeah, TypeScript is a very poor example of static typing, but I guess technically it is static typing, as well as Java. Dynamic types are like Python or Ruby, something like that. But I think Java and TypeScript would technically be called static typed languages. Yeah. Okay. Even if in, for example, TypeScript, you can kind of violate them on accident. Signal to noise ratio is too low. Yeah. Why do the types behave differently in TypeScript? Is that what you mean? Or in, like, for example, PureScript? And to be fair, I don't exactly know how you break the static types in Java very well, but I know in TypeScript that you can pretty easily. Oh, TypeScript versus Java. Yeah, so I think TypeScript is just a poor example of a type system because it's like tacked on, right? It's like an addition to the language later on. And because there's like, what, seven, like everything's a string in JavaScript. it can be really difficult to write a typing system for it. Yeah. I wouldn't call it junk because it is helpful in a lot of cases, but there are ways to like work around it. Okay, so yeah, this is noisy, and it has lots of like syntax that you have to like wade through to see what's going on here. Like in here we would just write, I can't type right now. Like this would just be a map of integer, list of string or whatever. Like that's it. That's all you need to write this. And same is true for hash map. Although there probably is a hash map, but I just don't know what it is offhand. Anyway, we'll get to more types later, I'm sure, but this is just so noisy for me now. And yeah, signal to noise very low. Here's some Scala code. Non-empty, parameterized on A. It has an elem, which is an A. I don't even know what this is for. I guess this is the first element. I'm actually not even sure what this is supposed to be. Non-empty what? Is it a non-empty list? What are you doing, kitty? Things on the left and things on the right. So I guess maybe this is a non-empty list stored as a tree. Something like that. I'm not sure. Anyway. You can understand why programmers are willing to abandon standard static types for the simplicity of this, or even simpler this. There's a high price to pay for dynamic types. Type checking is deferred until runtime. Yes, problem. Tests to catch type errors must be written and maintained. Yes. Refactoring is the scariest thing on earth. I've never ever once been scared to refactor my Haskell code, because the compiler just helps you. Like you just listen. I always like to say that I'm holding hands with the Haskell compiler and just walking gently to solve our type problems. Yep. One could argue the downsides of static typing are limits to the programmer's freedom. For me, this is a good thing. So I don't call this a downside personally, because humans are prone to error. Humans are prone to error. I think that this is not true in Haskell as well, or PureScript again. Sorry, I always talk about Haskell because it's my favorite language. It's like what changed. Like I would say that Haskell changed my life. Like I'm not even joking. Yeah, but like your tests don't like you can have tests in PureScript or Haskell as well, but like refactoring code is just easier in Haskell and PureScript because the compilers are so good. To be fair, I've never refactored Java code, so I don't really know what that's like. So it's probably a poor comparison because I just have it so good. All right, so perceived limits. Common belief with a dynamically typed language, you don't need to know what type of data you will get until runtime. Oh gosh, that's scary to think about. Okay, so yeah, if you feel that way, then I think that validates my point, I guess. Because like even if I don't have tests in Haskell, like I'm almost not scared to refactor. Yeah. I mean, it depends what code I'm touching, for sure. Like some code is more complicated than others. Yeah. Yeah, code with side effects is trickier, for sure. Like if you don't have any side effects, then it's trivial to refactor. Yeah, exactly. Again, I guess it's a good thing to point out that I said it earlier, but I'm going to say it again, is that you don't have to write Java where there can be side effects everywhere, but you're forced to do it. Like the human is forced to do that, not the compiler. Yeah, so great example of doing this is like, let's say somebody hands you a CSV of really dirty data. A dynamically typed language is going to be a lot easier to clean that data up. But that's not a program that you're meant to share with others. That's kind of the way I like to say it. Is as soon as you want to share code with someone else, static types are almost necessary. Yep. Okay. So. Yeah. Yeah. Agreed. Cool. What time is it? Okay, we got a few more minutes, so we're fine. Take the following bit of pure script code. Add x, y, x plus y. We can infer that x and y are some sort of number. A mathematician would say that x and y are members of a semi-ring, which is a magma. But, if you've never heard semi-ring, no big deal. Or magma, for that matter. That was a bit of information I learned from another book. How did we know what types were involved? We knew this because of the plus operator. It takes two numbers and adds them together. We inferred based on how x and y are being used, and this is, in essence, how the compiler infers types. Specifying types is important to help document code. It's kind of like, it's huge. Typescript has this. What is this? Sorry. Oh, the inference, I think is what you're referring to. But with type inference, we don't always have to specify the types. In this case, short local variables. This will reduce the burden. Okay, cool. So let's revisit our Java example. What makes this difficult to read is that the type information is intertwined with the variable names. In most ML-based languages... Oh, wait, I guess this is ML-based. That's a good point. I guess I don't think about it that way, but okay. Anyway, to separate the type information, the type signature from the function definition. So yeah, this is what add would look like, specified to integers. Technically, plus is more generic than just integers because of the semi-ring thing that was discussed previously. It's also overloaded so that you can use different types with it. Notice how the types are defined on a separate line from the function. That's funny. If you think the type signature looks strange at the first glance, you're not alone. And yeah, I would agree with this. Like, I think that a lot of people would understand what this means if you were like looking at, if you think about it as a function, like, but it can be strange, and it took me a while to get used to this. Yeah. Like, does this look weird to you, Dota? Just, I mean, it's add, so maybe it doesn't look as weird, but essentially this is like an uncurried version of the type signature. Curried? No, it's uncurried. Pretty sure that's the right term. We'll talk more about this later, but because I want to keep talking about FP with you, since you're relatively new, so the interesting thing about this is that you can partially apply functions in this language. So if you provide an integer to add, it will return a function of int to int. So we could write the following. Whoops, if I can't type today already, so I'm worried about work, but I'll probably get used to it. So let me write add. I'm still getting used to this keyboard, so ignore me, generally speaking. So we could say add 2 is int to int. And what that is actually just add 2. Sorry, my escape key. Okay, so here we have, yeah, don't worry about that. Here we've partially applied, we've passed 2 as an argument to add, and then that thing will return us a function from int to int. So if we wanted to write the function add 2, we could say add 2, that would be a function from int to int, and then this thing compiles. Because of the way currying works. And you also note something interesting here is I don't even have to provide an argument to this. So this is equivalent to add x. So that's called, what is this called? Why am I blanking on the name? Point free. So like that. Pretty cool. Okay. Why is that? What makes it not worth it? So okay, so I think there's another interesting point here that comes up. I'm glad we're talking about this because this is kind of fun. Thinking functionally or thinking as a functional programmer will arguably make you better at the other languages that you're used to, because you're going to think about things a little bit differently. Like you might say, oh, maybe I don't really want this effect here, or like maybe I don't want to do an effect here, and so I'm going to purposefully try to make pull out these pure functions to use later or something. I think that's, yeah, I mean, it doesn't need to be like a definitive answer. That's, I accept that. It's hard to do that in a textual medium. All right, so summary. A disciplined approach to programming has proven itself over the years. Not surprising. Functional programming's restrictions are no different from the ones introduced by structured programming. All functions are pure, no side effects. All values are immutable. Iteration is performed via recursion. Technically, you still get like loopy looking things. Like you can have like for loops and stuff, or each, or whatever. Okay, cool. So I think that was chapter 1. And then chapter 2 will be functions, which we'll definitely do at the, like, sometime this week. I think tomorrow, do I really want to start another book tomorrow? I kind of don't want to start this book tomorrow because we did do another like stream of just talking, and which is fine. Like I actually enjoy that. But I would like to get some exercises going because I think that's the most fun that I have between like me and the rest of the stream. So working on that stuff, it's very fun for me. Okay, so let me read this real quick. So it's not widely used enough, and the time commitment is massive. I would agree with that. It would pigeonhole me in the market I didn't want to be in. On the market, there's a tension you're going to run into with streaming. What do you mean by that? Tension. I assume, are you referring to closure out of curiosity? Because yeah, the more popular you become, the more you have to engage with chat and the less work you get done, which is totally fine. I'm doing this partly for me and partly because it's fun to talk with all of you. So it works out nicely that like streaming becomes very fun for me. Okay, so there we go. So that was chapter 1, and we'll do chapter 2 probably tomorrow morning if I get up in time. Otherwise, I will see you all next time, and